This is the screencast for section 2.4, example 3. We're going to find the tangent line to a curve. So a tangent line is, first of all, a line that touches the curve at a point but doesn't exactly cross through it. It just touches it. Now, that's a rough definition. As we go through this course, we're going to get a better idea and a better definition of a tangent line. But right now we are going to develop the equation of a tangent line. Well, any line needs a slope and a point to come up with its definition or equation. Because a tangent touches the curve at only one point, its slope represents the curve's instantaneous rate of change, or instantaneous slope, which you learned about earlier in chapter 2. As a matter of fact, this should look familiar. F of a plus h minus f of a all over h, the limit as h approaches 0. You have been finding the slope of the tangent line. Now I have a little visualization here to show you. So here's the tangent line that has an instantaneous slope of 4. Now, I'm not quite at h equals 0, but about a slope of 4. What we did was we took our x value 2 and then 2 plus h and found the slope of that line, that secant line. We're bringing that h distance closer and closer and closer to 0. So as we get closer and closer and closer to 0, that line turns into the tangent, right there, instantaneous slope. So if h is really big, we don't have an accurate slope. But the closer h gets to 0, we have an instantaneous rate of change, or the slope of the tangent line. So we call the limit as h approaches 0 of f of a plus h minus f of a all over h the difference quotient of f at a. A just represents a specific x value. Now I'm going to give you a heads up. In the next several problems, I'm not going to show you the steps on the algebra because I showed you those earlier in chapter 2. I'm just going to show you some basics about it, and then it's up to you to make sure you understand all the algebra getting through. So we want to find the slope of the parabola, y equals x squared, at the point 2, 4. Well, I already know that the point was 2, 4 because 2, f of 2, and then 2 squared is 4. I'm also looking for the point 2 plus h, a really, really tiny little bit. So that's going to be the x-coordinate. The y-coordinate is going to be 2 plus h squared. So that input plugged into the original function, squared. So my y1 will be 2 plus h squared. My y2 will be 2 squared. And then all over x1 minus x2. Expand out, simplify. Finally, I get to a point where I can plug 0 in for h without getting 0 over 0, and I get a slope of 4, which you saw in my demonstration. So now I have a point and a slope, so I can put that information into point-slope form. So I have y minus my y-coordinate of 4. At that point, I'm trying to find the tangent line. And then I have my slope times x minus the x-coordinate, 2. There is the equation of my tangent to the parabola. Now what I did here is I graphed in y1 the parabola, and then in y2 I just added 4 to both sides and put that in, and I found the intersection of the two of them, and it sure enough was 2, 4. So that tangent line just touched the curve at 2, 4. The now try problem number 11. We're only going to do parts A and B, C and D we're going to do later in example 5. But number 11 asks us to find the slope of the curve at the indicated point and an equation of the tangent line. Well, we have the x value 2. We got to find the y value. So the y coordinate then will be 1. So my point is 2, 1. Now I got to find the slope, which means the other point I'm going to use is 2 plus h, f of 2 plus h, which means the other point would be 2 plus h, 1 over 2 plus h minus 1. So I have to find the limit as h approaches 0. So I'll find a common denominator in the numerator. Now be careful, you're left, when you combine the fractions in the numerator, you're left with a negative h. And now I'll simplify that. And finally I get that the slope of the curve is going to be negative 1. So the equation of the tangent is going to be y minus the y-coordinate times the slope, which we said was negative 1, times x minus the x-coordinate of 2. And I graphed 1 over x minus 1, and then my tangent line on the calculator, and they do intersect at 2, 1, exactly where I wanted them to, and it does look to be tangent as well.